February 10th, 2021. I'm Daniel Ari Friedman, and today I thought I would do a little experiment, kick off a little Synergetics live stream. So let's get right into it. Today in Synergetics Livestream 1.0, there's a spirit for today, an intention, and several goals as well. So first, just on the side of the spirit for today. The goal is to have the intention of today's discussion be accessible, pragmatic, and exciting. So accessible, meaning that those who want to reach it should be able to reach it and to access it and have it resonate with their natural inclination. Pragmatic, meaning it should be tuned towards effectiveness, towards an end, towards utility, which is always informed by value as well, but utility nonetheless. And lastly, exciting, because it's an experiment for us all. It's learning by doing for us all. I don't have too strong of a plan today and just hastily whip this together because I thought it might be fun to give it a shot. And exciting is also a key part of Synergetics, because to be excited about this material is to want to love it more and to have the opportunity to love it more. So for those who are excited by Synergetics, I hope that it's something that you can return to again and again throughout your life and continue to be excited by it, because there's so much exciting within. On to the more logistical goals for today. The first part of the presentation, we will introduce this presentation, which is really just, I took a PDF of Synergetics, the red covered book with around 1,800 pages, and just saved it as a PowerPoint presentation, as a PPTX, opened it in Google Slides. So that is what we are working off of, and it was pretty cool to see that the links in the book actually linked well in the slideshow, so that will probably help us a lot. This presentation is just going to be who knows how many times treading through Synergetics. It could take a lifetime to go through even a subsection, just like other domains of human knowledge. But again, this presentation is just going to be jumping around to a few key places, and throughout the live streams, we'll come back to different sections again and again. Today, it's just me, but tomorrow, maybe you'll be on here, or maybe somebody who you want to hear more from. The key memes and themes of this presentation are on the next slide, so we'll look at that in a second. But the key memes and themes are going to be a core set of ideas that we're going to recurrently return to. So strange attractors or nomadic ideas, no matter how you think about it, these key memes and themes are parts of Synergetics. Now, whether they're axiomatic, so they're assumed and Synergetics is downstream of them, or whether they're a consequence of some synergetic axioms, or whether it's just a way of thinking about it, or a helpful prompt, or a metaphor like a bridge to a non-synergetic world. All these things and more we hope to include and curate in this key memes and themes page. There is then a things to integrate slide number 4, and the things to integrate slide will contain ideas for next time and topics to include. So anytime that people have suggestions or thoughts about what could be included, what should be included, where can we take the Synergetics live stream, let's give it a shot. I think having somebody to converse with, or a good e-slide reader, some text-to-speech reading for a little bit of a dialogue with a text, or anyone else who wanted to join, whatever their background or familiarity is with Synergetics, dialogue is an incredible way to learn by doing with Synergetics. So I hope to have that accomplished maybe at some point within 2021. After the introduction of the things to integrate, then from the text, we'll go through 3 sections with a first pass. And the 3 questions that we're going to be addressing with the sections from the text today are: what is Synergetics, in Bucky's own words? What is universe? And what is system? So for those of you who are curious about Synergetics, you're going to hear what Synergetics is. For those who would want to understand, why is he pulling back so far? Why does Bucky pull back to universe? Why doesn't he call it the universe? Why is it just universe? What is system? So systems thinking, complexity thinking, design thinking, all these topics will come up. And Bucky was such a unique character. He had such a unique way of talking about these ideas. So some of the words might be new, but just think of it as a mural. It's many coats of paint, and we're always deepening in our understanding of Synergetics, which isn't strictly about Bucky, but he was the one who compiled this book to a large extent. So those will be the 3 questions we'll go through. All right. So the key memes and themes pages. So these are going to be memes and themes that we return to many, many times and continue to tweak, locally improve how we can say them, or perhaps translate it into a different natural language, a different human language, or into a programming language. Local adjustments to the key memes and themes is also a space for global improvement in the key memes and themes. So if there's something fundamental, something you would whisper in the ear of somebody who you are going to then send off on a journey to use Synergetics, these are the kinds of things we want to include on this page. And I just listed out a couple of them in truly no specific order because I figured that in the spirit of learning by doing, it was better just to write down a few things that were on the top of my mind. And then as we come back through these ideas, even today during the stream, we can improve and add on this page. So Synergetics is relational and multiscale thinking. Relational thinking means that the emphasis is on the relation. It could also be considered anti-essentialist thinking. Essentialist thinking is the idea that the identity of something, its essence, is contained inside of it. Whereas we could contrast that with relational thinking, which says that what it means to be something or the functional significance of something is actually defined in relationship to the ecosystem, to the niche, to others in a social context, to other members of the structure in a building context architecturally. So relational thinking is somewhere above reductionism and somewhere closer to holism and network thinking. Multiscale thinking is related to the idea that physical and even mental systems are nested within each other. And that means that smaller things are inside or contained within bigger things. And the multiscale thinking or the fractal thinking approach is the idea that we want to be having a framework that doesn't prioritize smaller or faster things over larger or slower things, but rather is an integrated approach that contains bigger things that scaffold smaller things and vice versa, sometimes also called the top-down and the bottom-up approaches. So very close to complexity thinking and also many traditional knowledge systems, which is why it's so exciting to learn about Bucky's work and also the various perspectives that he incorporated in his work through traveling around the world and studying so many topics and always putting it into his own words and his own experience first. That's related to this second point, which is that Synergetics is connected to accessible experiences. And I don't think it's going to come up in the 3 sections that we look at from the text today, but there's a section on the child as scientist and on the need to have claims that can be demonstrated in the moment to a child. So how would you demonstrate that the world has a curvature to it? Or how would you demonstrate that the sun and the earth are in a certain relationship to each other? And it turns out that just go, hey, look at Wikipedia, look at the textbook. That's not the synergetic approach. We want to have at hand, comprehensible, graspable ideas that can be conveyed at the kindergarten level. And I've heard so many funny anecdotes about Bucky and somebody who would ask him a complicated question and he'd have a simple response, or they would say something that maybe outside of the Synergetics context would be considered as complicated, and Bucky would refer to it as just kindergarten. So we can think highly of ourselves and of our children and want them to be educated well. So let's keep it accessible, but also deal with it with rigor. The third point is that Synergetics doesn't have infinitesimals, nor are there points, lines, or planes in the sense that somebody who is trained up in a non-synergetics perspective would understand. What does this mean? So if we take for granted that things that exist are actually existing, then they have to have some physical manifestation, representation, perhaps. So the story that Bucky told about why he was against the points and lines and planes was, he said a teacher put a dot on a chalkboard, just put a single little mark and said, this is a dot. It has no dimension. It has no length, width, height. It doesn't have any mass. It doesn't have any weight. So, of course, what is a point? And a mathematician might say, well, that's the asymptote. It converges to being a point. But we're taking that from the other side. We're saying, okay, so then there is no such thing. It's a heuristic. It's something that is asymptoted towards as things get small. But points, per se, can't exist. Well, how about lines? A line is a stack of infinitely many points, which still have infinitely low volume or zero volume, so the line has no volume. Now you take it to the plane. A plane is defined by 2 lines. However, the plane still has no volume because it's still just basically points and lines or however you want to think about it. And all of a sudden, you stack a couple planes together and you get a space enclosing solid. And so when Bucky saw that the planes were being appropriated together to make something that was space-filling and actually could exist in the real world, he asked how it was possible to generate something that contained space and had potentially even mass and other attributes from things that didn't. And so again, it's kind of a parable, like many from Bucky's life, that are used, whether they happened or not, to symbolically reflect aspects of the differences between synergetics and not synergetics. And there are things that are too small for us to see. There are wavelengths that are so high that we can't detect them. In fact, we can only detect the wavelengths with our eyes of 400 to 700 nanometers of light. Other wavelengths don't even fall on our radar, so to say. And even the ones that we can see or perceive, we don't perceive them as discontinuous or as oscillating. A sound, for example, a bell ringing, might sound pure, but actually it consists of an oscillation movement. So there's things that seem like they're continuous or homogeneous, but actually they're composed of physical things. And another example we can think of there is the elements. So people might have thought that water is made up of water. However, you go down a little bit and there's actually a granular or discrete nature. Now, that doesn't mean that reality at its core is granular or discrete, because it can be packets or parcels or continuums of energy, but still there is a granularity in the ratio that hydrogens and oxygens are being combined. And so Bucky, like many others going back to Plato and before, was very skeptical of irrational numbers and wanted those integers to appear all the time. And that led to a couple interesting things, which we'll come back to in a second. Another piece of synergetics is that in the context of synergetics, design is an anticipatory, which means cybernetic, science. So for it to be a science means that it's something rigorous, and it's something that's based upon experimentation, on professionalism, on including multiple people's perspectives, on a tradition and a culture of mentorship and of helping each other out. So that's what science is, or part of what science is, could be. And the fact that design is seen as anticipatory or cybernetic. So it's goal-seeking, and it's in advance of other problems arising. And so maybe somebody thinks, well, design as anticipatory science, what is that even about? Well, think about designing a roof. It's in anticipation of, for example, wanting a roof. You can't just have the roof appear when you want it. You need to have an anticipation, and an anticipation that's driven by the niche and by the needs of the individual in a scientific concept, which doesn't necessarily mean professors, but it means that people who are trying out different kinds of tent design are sharing it, and ones that are successful are gaining ground. We'll return to how you get things that look like points, lines, and planes later, but just not at this moment. One analogy that I've been thinking about and working with is this idea that tensegrity is related to synergetics in the way that engineering is related to physics. So tensegrity and synergetics, and then engineering and physics. Tensegrity is a more applied and a more physically manifested science. Tensegrity is used to build everything from solar foils in the Earth's orbit to shapes like the geodesic dome to micro-scale structures. So there's so many uses and cases for tensegrity architecture, but tensegrity fundamentally is about the relationships of tension and compression, hence tensegrity. And so tensegrity is about physical things. Engineering is about the application of physical things as well. Whether it's electrical engineering or civil engineering, it's about applying and pragmatics in a certain domain. We can contrast that with the more esoteric of each pair, which is respectively synergetics and physics. So synergetics, and the subtitle of the book, as we can see here, is Explorations in the Geometry of Thinking. So although we're going to be seeing a lot of figures, this is actually about the geometry and the topology, the vectorial geometry, as Bucky called it, of thinking. So these are representations, they're metaphors, they're symbols, they're tokens. There's a lot of ways to talk about it. But like physics, which might draw inspiration from the physical world, like mixing particles or work being done, but then very quickly verge into theoretical physics or mathematical physics, there's different areas, but there's clearly a continuum from the more applied domains in engineering to the more abstract and theoretical domains in the physics department. And that's not to say there isn't interplay. In fact, there is interplay. The engineer says, hey, I'm seeing this weird phenomena. The end user of the machine is seeing some phenomena. The measurement is coming out in a way that wasn't predicted by certain types of expectations from equations. Sends that to their physics colleague, who reintegrates it into a more accurate, abstracted understanding. And so many times we've seen new breakthroughs from people's direct apprehendable experience on the engineering front, so to speak. And similarly with Tensegrity, we can build things like I have a little spring tetrahedra behind me, and by playing with the physical structure, it can help inform us about the structure of thought. Shape and space, interesting words. One thing that we'll come back to is the idea that space has a shape. What shape is it? And it's not going to be just a single or simple answer, although perhaps for some it is. But this is to say that space does not allow you any configuration, for example, of spheres being closely packed. There's a few specific ways that spheres can pack, and you don't have the choice to do other options. So there is a certain shape, just like if there was a certain a grid, and you were going to put your socks into each of the little cubbies into a grid. And so you'd say, my sock drawer has a shape because I can only put things into certain spaces. And if I try to put it here, it rolls into here. And that's similar actually with just packing spheres. So whether you're packing bowling balls or oranges or atoms or ideas, there are certain relationships that are permissible or lower energy or seem to be preferred as the arrow of time progresses versus other configurations that are either unstable or can't be reached. We'll get back to that more. Structure is pattern. Pattern is regularity, and that regularity can be static or it can be dynamic. So we talk about integrity and about the structure integrity versus the pattern integrity. So structural integrity is like a strong building that is maintaining the integrity of its structure amidst forces. Not all forces, but some forces in that moment until the limits of the resilience are tested. On the other hand, the dynamic or the pattern integrity is, for example, an organism, where each organism never revisits the same exact point in development. However, through populations of organisms and reproduction, we end up regenerating the integrity of the organism through a dynamical process that doesn't involve preventing things from changing each version of the system, but rather having the versions of the system work together so that future versions can be healthy. Another key meme and theme that we'll return to many times is this idea of 4D, which Bucky basically used as kind of a trademark and a symbol. And there's many meanings of this 4D, and we'll come to some, but hopefully we'll build out this list because 4D is sort of like a magical key, and it's a reminder to think about things four-dimensionally. So non-linearly or from a higher dimension, from the perspective of the tetrahedra as the base unit, not the square. So two things falling out of the tetrahedra being preferred over the square as a base unit is, first off, there's a focus on 60-degree angles and on triangles rather than on 90-degree angles, right angles, and squares. There's also a recalibration of the volume of space, so that if we imagine the 1 by 1 by 1 unit cube, so if it's 1 centimeter on all sides, then it's going to hold 1 milliliter of water, it's going to weigh 1 gram, it's going to take 1 kilocalorie, to etc. So 1 kilojoule, I'm not going to go into the thermo, but basically the cube is the piece that ties all of the physics together in our Euclidean system. So everything about squares and volumes, it's like, well, you just multiply the height by the length, the height by the width by the length. And that's how you get the volume of a square. And so 1 by 1 by 1, 1 times 1 times 1, that equals 1. So the unit cube has a volume of 1. We're going to see a slightly different way of calculating volumes in the book and in the work of Synergetics, where actually a tetrahedra with a unit side of 1 is given a structural quanta volume of 1. And we'll see some implications of that. But again, there's multiple ways that this 4D idea plays out. And Bucky weaves them together just so closely, such a tight fiber, such a deep understanding of the topics that we're going to be coming back and adding people's perspective just forever, because there really isn't going to be an end to this one. Lastly is the things to integrate. So on this slide, hopefully we will list notes that arise and any next steps that could be relevant for our project. So this could be things that we want to include in the next Synergetics live stream in 2, or it could be things that we want to do as projects, as a community of practice. There's a lot of different pieces to what we could be doing in this things to integrate slide. The one piece that I'll just say right now is that the link to modern and computational approaches to Synergetics has been something I've been curious about and interested in for a long time. And I've given a few resources here. I've shown the grunch.net resource of Kirby Erner, as well as his GitHub. And it's actually Kirby's videos in part that really inspired me to make this live stream and start this little journey in 2021, because his videos are quite funny, fascinating, great stuff, and I've really appreciated learning from him. Also, I'll point out the Tensegrity wiki, which is a developing resource for Tensegrity and for Synergetics and a lot of other associated projects. So there's a ton of cool stuff happening over there, and I'm not a contributor to that wiki. I'd like to learn more about how to do that, as well as to start maybe drawing material or colleagues from the Tensegrity wiki, because it's a great effort that they're engaged in. And hopefully, if anyone leaves a comment or a thought, you can also post in the live stream chat, probably on YouTube, and I'll try to add this things to integrate into a future presentation. So that will be cool. All right, well, that was good for 20 minutes just to talk about the introduction to the live stream, the key memes and themes for today, and this things to integrate idea. So now we are going to get into the text itself and just go through these 3 questions. What is Synergetics? What is universe? And what is system? And again, it's just a first pass. This is not something I've prepared for, just skimmed through the sections before this. So it's just a first thought, not a final word. And it's always about people's perspective. So I'll have different perspectives in the future and you'll have a different perspective. And that shape that we make with our perspectives is the strength and the beauty. So let's be open to perspectives, to being wrong. Let's learn by doing and just jump right into Synergetics, because again, there's so much to learn if we can just open our eyes to it. And so I'm just excited to be diving back into this material with a new spirit after reading it. And a few of the Bucky books I have are over here. And so for being a fan of Bucky for many years, to be in a position where I'm able to live stream and to work through this material, hopefully with a growing community of other curious people, I'm just really looking forward to that. So the first thing we'll go to, this being Synergetics live stream 1 and whatnot, is decimal point notation 200.0 Synergetics. And Synergetics, it's written in an interesting way. It's a physical book, and there's 2 volumes. The first volume was published, and the second one was published. R. Buckminster Fuller's name is in large font. It was written in collaboration with E.J. Applewhite, who provides a disclaimer basically saying everything in this book is Bucky's idea. I just confronted himself with himself. And also Arthur Loeb, who is a crystallographer at Harvard, I believe, wrote a preface and added some extra commentary. So there's these 2 volumes of Synergetics, and rather than just saying page 55 or in this printing, this chapter number, there's a decimal notation. Now, there's probably a lot of nuance to why the numbers were chosen and which numbers were and weren't used. Hopefully some of those patterns we'll see coming out as we go. But basically, the decimal notation allows the 2 books to be referencing kind of a common Dewey Decimal System of ideas. And also it allows very simple cross-linking. So it's almost like a wiki with these references that jump between different chapters, and I could imagine it being on Git and actually being versioned. So we could say, okay, well, that was the 762.01 of this version. And then this was appended to that, or this was edited here. So let's go to what is Synergetics 200 on slide 89. All right, so for reading the text and also seeing Kelly Ritchie's group has been pretty educational here. There's probably a lot of ways to do it, and we will again learn by doing and figure out how we all like it. So if people on YouTube or on the comments of any platform want to just give a suggestion, that'd be great. And if there are ever any other people on the stream, perhaps one person could read it and another person or everybody's voice could respond. But it being just me here today, I think what I will do is for each of the numbers, I will first just read the text straightforwardly, the whole number straight through, because Bucky clearly put enormous care into how he used his words, especially in writing as well as in speaking. And so to hear it without any interruptions is actually quite important, because there's probably multi levels of meaning embedded within the very specific ways in which it's actually written. So I'll read through it once. Then I'll read through with sort of a YouTube style comment breakdown. So maybe a word that needs definition or a question or an uncertainty that I'm having. Then I will try to find an example of this principle in action and then a question, whether it's a question for one of us to think about or whether it's an uncertainty, again, that we're still having with this section of the text. So we're going to keep moving and stay positive, while also understanding that it's going to be a long game to learn and understand synergetics. It's really a lifelong project, which is totally great and fine. So here we go. Again, reading through straightforward once, then read with breakdown, then with an example, and then try to think of a question as well. All right, so, and as I was saying about the numbers. So here we are in section 200.00 Synergetics, and then there are subheaders that are related to the decimal notation. Synergetics promulgates a system of mensuration employing 60-degree vectorial coordination comprehensive to both physics and chemistry, and to both arithmetic and geometry in rational whole numbers. Synergetics promulgates, or puts forth, a system of mensuration, which is measurement, employing 60-degree, so again, edge of a triangle or a tetrahedra, not a square, vectorial coordination, so that's telling us that there is a coordination, a co-ordination, or a co-navigation. Things are being related to each other in a co-fashion. And that coordination, the ordering of the coordinates, is going to be vectorial, which means it's going to have a dynamic attribute and it's going to be occurring through time. It's not going to be a static coordination. It's not going to be a static reductionism or a static essentialism. It's going to be a vectorial coordination, and it's not going to be 90 degree, it's going to be 60 degree. Comprehensive to both physics and chemistry, so including or transdisciplinary physics and chemistry as well as other fields, so kind of saying it's going to include all disciplines, and to both arithmetic and geometry in rational whole numbers. So arithmetic being the addition or operations usually on integers, and geometry being about angles and about some other things as well, shapes, the shape of space. And that is going to be integrated in a rational whole number framework. That's the breakdown to me of this first piece. So one example of how we could break down, let's just think of, again, in the example of a system that would be comprehensive of both physics and chemistry and use rational whole numbers. How about the methane molecule, CH4? So it's one carbon with 4 hydrogens bonded to it, single bonds. And it turns out that that splays out in the maximum entropy way into a tetrahedra. So the orbitals for carbon hybridize into this tetrahedra shape. And so CH4 is something that is comprehensive to both physics and chemistry. There's this chemical reactivity of the molecule, but also there's the physics of the protons and the electrons and so on. And it's a vectorial dynamic tension and compression geometry, and it's in rational whole numbers. It's not 1.11111 to 4, it's 1 to 4 carbon to hydrogen. A question that I would have about this, first off, is will this comprehension go beyond physics and chemistry? Will it include biology? Will it include other areas we care about, psychology, sociology? And then also, how will we ever prove or disprove or find evidence for or against this notion that rational numbers are to be avoided? Irrational numbers are to be avoided. Not exactly sure where that idea comes from and would want to know more about that. 2. Synergetics originates in the assumption that dimension must be physical, that conceptuality is metaphysical and independent of size, and that a triangle is a triangle independent of size. I love it. Let's read it through with a breakdown. Synergetics originates in the assumption, so these are going to be some axiomatic claims or underpinnings to synergetics, which may or may not need to be supported with evidence because axioms are claims that cannot or are not supported by evidence. The assumption that dimension must be physical. So to have existence in the real world, you need to have physical existence, okay? To have the email address, you got to have the email address. To be physical, you need to have dimension. If it's not having dimension, it's not physical. Now, there's nothing wrong with it being not physical. In fact, he writes, conceptuality is metaphysical and independent of size. So this means that ideas are not sized in the same way that shapes are. We might say that's a small idea or a big idea, but that's not a reference to the physicality of the dimension of an object like a building. And a triangle is a triangle independent of size. And so a triangle is a relatedness. It's a way that actually 6 things are related, which is 3 points, 3 vertices, and their edges. And the relationships of vertices and edges and angles and volumes and shapes, we're going to go into that so much. But the idea here is just that the metaphysics of a triangle is independent of its size. So a physical thing on the ground is always specifically only its size. Like if you make an iron thing that looks like a triangle and someone says, oh, that's a triangle. Well, it's actually iron in the shape of a triangle, so it always is going to have width and length and height and things like that. The vertex is never going to be vanishingly a point. The edge is never going to be vanishingly thin. But what humans can do as generalizing information foragers is go, whoa, we could actually make like the ultimate lightest, thinnest triangle ever that's asymptotic, that actually doesn't even have physical existence. And that's this idea of the triangle. So an example of this is the difference between a physical, for example, a hula hoop, and a circle. Circle is conceptual, it's metaphysical. Hula hoop is physical, it's always going to be physical. And a question I would have would be, how do the physical and the metaphysical interact? Since physical universe is entirely energetic, all dimension must be energetic. Synergetics is energetic geometry since it identifies energy with number. Energetic geometry employs 60-degree coordination because that is nature's way to closest pack spheres. So, since the physical universe is entirely energetic, so E equals mc squared, there's an equivalence between energy and mass. Mass and energy are related kinds of things. So, physical universe entailing physical existence and dimension, and physical dimension entailing something on the mass-energy continuum, we can then say physical universe is entirely energy because everything is energy. All dimension must be energetic. Again, because all dimension is physical, everything physical is energetic. Synergetics is energetic geometry since it identifies energy with number. And so, again, in point 1, we see that rational whole numbers are going to link up arithmetic, number, and geometry, shape. Here, we see the idea that energy is being linked with number. So we're linking up in many different combinations, number, shape, and energy. Those ideas are all coming together. Energetic geometry employs 60-degree coordination because that is nature's way to closest packed spheres. And so, this relates to what axiomatically do we choose as our coordinate system. So 2 different coordinate systems that people might be familiar with. One is the Cartesian plane. So that's x, y, z. 3 axes that are at 90-degree angles to each other. And in that world, or in that coordinate system, there's a 90-degree coordination between the axes. You could also imagine polar coordinates. So describing any point as being in relationship to an origin with a certain rotation, elevation, and distance away on the sphere. So that's also a way to use 3 numbers to identify any coordination. And it turns out that this energetic geometry is going to be using 60-degree coordination because that is how nature closest packed spheres. So maybe there's a few ways that Bucky gets at it, but part of the way he operates is he starts from the observable and says, given how I know oranges fall when you arrange a million oranges and they pack a certain way, and they don't just perfectly line up like a grid, an XYZ grid, would it make more sense to have a coordinate system that was about close packing spheres, or would it make more sense to have a system that is abstracted potentially in a way that's going to be misleading? And example of this is the way that thought, which is entirely metaphysical, is related to the universe, which is entirely physical or entirely energetic. Again, physical doesn't just mean hard like a table, because even that we know is just energy. So physical, no shade being thrown. It's all cool to be physical. And a question I would have would be, how do we know we've discovered all the ways to pack spheres, or what is the relationship between thermodynamics and sphere packing? 4. Synergetics provides geometrical conceptuality in respect to energy quanta. In synergetics, the energy as mass is constant and the non-limit frequency is variable. So synergetics provides geometric conceptuality in respect to energy quanta. So quanta are discrete packets, so 1, 2, 3, etc. Those are quantized. Synergetics is going to be a framework that provides us with shape, that's geometrical, conceptuality, that's metaphysical. So it's going to give us the shape and the metaphysical ability to interface with realized energy quanta. In synergetics, the energy as mass is constant. So there's not going to be, at least in Synergetics 1, there isn't going to be a nuclear transformation. There won't be any nuclear alchemy. In other words, the energy of the mass is going to be constant, but the non-limit frequency is variable. So the resonance of the system is going to be variable, even though the mass is not going to change. So here's an example of that. Would be like if you had a geodesic dome that was built on tensegrity principles. So rods that were compression members and wires that are tension members. And it turns out that if you poke it and you hit it with a hammer, it will resonate at a certain frequency that is distributed along the surface by these stress vectors. Now, if you dampen one of the rods, it actually increases the resonant frequency of the rest of the dome, because it's going to be unable to dissipate stress through that mode, and that will lead it to actually resonate faster and faster. The more fragile something is, potentially the more fragile that it is, the faster the resonance is going to be. And so the mass of the geodesic dome is not changing as you dampen different members. However, the non-limit frequency is variable, and that can be continuously tuned. And a question I would have would be, how do we know that energy is in quanta? And what if the quanta are so small that they're functionally continuous from some perspective? 5. Vectors and tensors constitute all elementary definition. So a vector is basically aligned with the direction, and a tensor, there is a few ways to think about it. It's one way is a vector through time. Another way, the more general computer science understanding, which Bucky foreshadowed, but maybe did or didn't interface with, would be like TensorFlow, where a tensor is actually just the generalization of a matrix. So you have a vector. This is thinking with a computer science definition. So instead of the vector being the arrow with a direction, now a vector is just going to be a list. So if you're in Python or R and your data type is a vector, that's basically what it means. It's like a vertical column. A matrix is like an M by N set. It's, you know, a bunch of vectors of the same length next to each other. So it can't be a ragged matrix, but once it's like a square or a rectangle of any kind, it's a matrix. And a vector is like a matrix with a width of 1. A tensor is like a bunch of slices of a matrix. So that could be time 1, 2, 3, 4, 5. And it could be your matrix is representing, you know, X by Y at time point 1, 2, 3, 4, 5. But that can even be generalized beyond the third dimension of the matrix going into a tensor. So vectors and tensors, maybe just to say representation or dynamical representations, constitute all elementary definition. I'm not sure if where sometimes these pluralizations, definitions, or all elementary definition, is that just saying the simplest definition of something, like high definition audio, the elementary definition, it's going to come back down to vectors and tensors. Seems interesting. It's possible. My question would be, Do other people think that this says something similar? 6. Synergetics shows how we may measure our experiences geometrically and topologically, and how we may employ geometry and topology to coordinate all information regarding our experiences, both metaphysical and physical. Information can be either conceptually metaphysical or quantitatively special case physical experiencing, or it can be both. The quantized physical case is entropic, while the metaphysical generalized conceptioning induced by the generalized content of the information is syntropic. The resulting mind-appreciated syntropy evolves to anticipatorily terminate the entropically accelerated disorder. So synergetic shows how we may measure, that's the measuration in point 1, our experiences geometrically, which is about shape, and topologically, which is about how things are connected to each other, and how we may employ geometry and topology to coordinate all information regarding our experiences. So we're going to use something that contains shape and connectedness. So it's a relational or a vectorial geometry. It's related to geometry and topology, as well as number, mathematics, and arithmetic. And that is going to be coordinating, co-localizing, shared sense-making our experiences through all the information. And that's going to include the metaphysical and the physical. So that's the energetic, the measured, the quantized, that's the physical, or the unmeasured, the non-physical, metaphysical. Information can either be conceptually metaphysical, again like triangle, or quantitatively special case. Physical experiencing, like the iron triangle or the hula hoop, or it can be both. So again, always just have like a simple example to fall back on. Let's think about just an abstract triangle versus a physical triangle that you build. Or you draw a circle with chalk on a board, and it's abstractly, metaphysically a perfect circle with no weight and no distance, etc. But as you zoom in physically, you find out that actually it's like these little crystals of jagged size, and it's not a perfect curve, and so on. So there's always the idea, the metaphysical, we can get Platonic with that, and there's the manifestation of the physical. Or it can be both. I wonder how it can be both. The quantized physical case is entropic, means it falls under the laws of entropy, so it's losing order to the environment, while the metaphysical generalized conceptioning induced by the generalized content of the information is syntropic. So first, syntropy we can take to understand potentially Schrodinger might have called it negentropic, so resisting the forces of entropy. Here we go with this sentence. The quantized physical case is entropic. So we have that iron triangle is going to rust. Whether it rusts slowly or whether it rusts fast, it must rust. It has to break down. So the quantized physical case is always going to be related to the laws and fall under the purview of thermodynamics, aka entropy. However, the metaphysical, non-physical, generalized conceptioning, so I see a bunch of different triangles. I see 10 different iron triangles. Some are really rusted and some look really new. But then, like the Buddha, seeing that people fall sick, for example, one could look at those sequence of triangles and they could think, maybe there's this thing or this idea, it's an idea thing, called triangle, that links all of these ones that look very shiny versus the ones that look used versus the ones that look totally messed up, maybe even bent, maybe even crumpled up or broken, missing a side. But still there's something that's abstract that can be linking them together in the relational eye of the observer, and that's the idea. Now, this generalized conceptioning induced by the generalized content of the information is syntropic. So all of a sudden, by generalizing across the special case iron triangles, our triangle investigator is now seeing order where there hadn't been. So now there's three things that are moving away from each other. That's in the entropy world. But then the person with a syntropic idea can now link them into an energy triangle or a metaphysical triangle. So that's creating order in the mind. The resulting mind-appreciated syntropy, so syntropy, which is only ever experienced or appreciated in the mind. It's like beauty is in the eye of the beholder. This is like saying order is in the eye of the beholder. It evolves or develops to anticipatorily, so ahead of time, terminate the entropically accelerated disorder. So that means the agent that's able to appreciate in its mind syntropy will evolve naturally, just like natural selection, to ahead of time. That's the anticipatory cybernetic design science. They'll evolve to terminate that accelerating disorder, that entropy slide. So now we have the example, the person sees the 10 triangles on the ground, some are new and some are broken. And there's a pragmatic use and end. The triangles are used to connect 3 horses that are in a field or something like that. You don't want the triangle to break. It's supposed to be strong. And it turns out you don't really care what the rust on the outside looks like, but you do want to keep it strong, because if one day you try out all your triangles and they all break, then your family is going to be hungry. So you want to be able to generalize across this triangleness that you're seeing, not just to understand in a metaphysical way, but actually to become the kind of entity syntropically that evolves to ahead of time design to terminate that disorder. So maybe you find out that some of the triangles were being stored in salt water and some of them were being stored in oil. And the ones that were stored in oil still look new, and the ones that were stored in salt water are getting very rusty. So then the individual who has used their triangle idea to abstract above the physical, because without the idea of a triangle, you might not make the connection between the rusted one, the broken one, and the healthy one. So now with the right abstraction, we're able to have our function in mind and therefore act pragmatically, hopefully accessibly, to do what? Change the system. 201 is experientially founded mathematics, which is a very interesting section, which goes into more about vectorial geometry. And I'll just write it down. I'll say we'll pick up on this front on 201 on slide 89. So things to integrate for next time. One thing will be, it's a little slow when there's 1,800 Google Slides in one, but so maybe I'll just put it in there. Deal with the formatting later. All right. Next, we were going to go to, that was what is Synergetics. So that's the first pass of what Synergetics is. And it's just many coats of paint. There's never going to be a single best take on this. There's just working through it and hearing it a bunch of times and folding it just like a tetrahedra in your mind, inside out, jitterbug, make it all happen. What is universe? Slide 203, section 320. Slide 203. Oh, all right. Section 320, scenario universe. When people say of universe, I wonder what is outside its outside. They are trying to conjure a unitary conception and are asking for a single picture of an infinitely transforming, non-simultaneous scenario. Therefore, their question is not only unanswerable, but unrealistic, and indicates they have not listened seriously to Einstein and are only disclosing their ignorance of its significance when they boastfully tell you that the speed of light is 186,000 miles per second. When people say of universe, I wonder what is outside its outside. That is like someone saying, what is beyond the so-called event horizon? What is outside of the universe? And you'll probably, it's a Google suggestion, right? What is outside of the universe? And Bucky is saying, you're delusional with that question because it's framed in terms of the universe as opposed to something else. So you got to drop the because there's no other option. So there isn't anything outside of universe because that would be part of universe. Uni, one. University, just one of them. The universe. They're trying to conjure a unitary conception of basically a universe that's simultaneously unified yet distinct from other things, and are asking for a single picture of an infinitely transforming non-simultaneous scenario. So non-simultaneity is going to come up a ton of times, and it's sort of like when a lightning bolt goes off, a lightning strike, you see the light, and then there's the sound that follows later. So it's like there's this sphere of the light that travels very rapidly, and then there's the sound that travels through a different media, different way, but it travels more slowly. And so we can take that differential and we can have a generative model of a lightning strike and understand that they're both caused by the same event, even though one of those spheres took a lot longer to impinge into our experience. And so the non-simultaneity of our universe means that everything's just kind of plugging and chugging along locally. So, you know, paging Wolfram, Bucky. There's a lot to go into here about how that's happening, but there's no clock time that's synchronizing the whole scenario. There's just local events, local happening, And then that is related to these expanding spheres that make certain types of events connect. The question is not only unanswerable, but unrealistic, which is often the case for questions that come from a different paradigm than, paradigm A asks a question to paradigm B, and it's not just that paradigm B has a response that's a hot take or funny or convincing, it's that the question doesn't even make sense. And I'm sure one can think of many examples like that related to different faith traditions or different secular perspectives. It indicates they have not listened seriously to Einstein. I don't know what exactly he's getting at here, because I see Einstein as just one player in a broader, sweeping understanding of space and time. And so he's getting to the point where it's saying it's a boastful tell that the universe is going as if the universe was static, like a playground, locally, and then light was being beamed out across that playground at a certain clock time. So that he's suggesting is not the nature of universe. You cannot get out of universe. Universe is not a system. Universe is not a shape. Universe is a scenario. You are always in universe. You can only get out of systems, which is good because we're going to return to systems in a second. You cannot get out of universe. Universe is not a system. So right away, we basically can see that universe is the total top level thing. Can't get out of it. No way around it. Truman Show, dome, whatever it is, that's universe. Then there's system, which is going to be something that is something you can escape. So a star system would be the sun and the star, but you could escape that star system, but you can't escape universe. Now, universe is scenario, which means it's set up a certain way and it has certain rules of evolution. And you are always in universe. That's a corollary of not being able to escape. An example of this would be all of our existence. It's kind of like, what is water? We are in universe, and so it's the water we swim in. And so the example would be anything you could think of is going to be in universe. Either it's going to be a hypothesis about a physical dimension of energy somewhere. I think there's a brick outside of my door, or I think this has this wavelength of light. Those are hypotheses about physical things in the world, which are ideas. And then there are the metaphysical things in our existence, like our experience and all these things we were just talking about on a couple slides ago. So a question I would have would be, how do we define different systems? Do they have a Markov blanket or a Friston blanket that separates them? How would we empirically or a priori partition systems in a way that's accessible, pragmatic, exciting? Maybe? 3. Humans have always tried to conform their concepts of universe to their own human prototype. Humans stop and start, sleep and wake, are born, grow, decay, and die. So humans thought the universe must also have a beginning and an end. Now astrophysicists find this to be untrue. There could never have been a primordial chaos simply because the scientists now know that the proton and neutron always and only coexist in the most exquisite interorderliness. There could never have been a time when their integrity was not an integrity. Interesting claims. So as I've written about and thought about elsewhere, I am often provoked by the claims that Bucky makes about physics or about what scientists do or don't know. And so that's what's so fun about reading and going through the text in this way is, let's be clear about what Bucky said, which he wrote in collaboration with E.G. Applewhite. And then let's be clear about our take on what he wrote. And that's the beauty of Synergetics as a starting point, is that there might be pieces where you would have put a different word, or you wish you could have gone into more or less detail, or you don't see how A follows from B. It's all chill. That's how he wanted to put it out there in the books. And what we do with the information is something different. So we're not beholden to any interpretation that we provide or that is implied from what Bucky provides. We're just looking at this text as like an open door and trying to understand it. So humans have always tried to conform their concepts of universe to their own human prototype. Now, as an evolutionary biologist, I would say this sounds like niche construction. It's like saying organisms are always conforming their niche to their own generative model to the extent they can. Basically, the organism can either update its generative model of the niche, or it can modify the niche, or both. But if it doesn't manage to do one or the other successfully enough, you're not going to see that organism in that niche. Humans stop and start, sleep and wake, etc., etc., etc. So humans thought the universe must also have a beginning and an end. So often Bucky will appeal to a psychological interpretation of history. So, suggesting that potentially across cultures, because there are certain biorhythms for humans, the universe was implicitly or explicitly linked to also having those biorhythms. It's possible. I don't know what all knowledge traditions have discussed. I don't know how many believe that the universe has a beginning and an end. There's many ways of thinking about the beginning and the end. Now, astrophysicists find this to be untrue. One could debate what astrophysicists know in 2021 or 1951 or 1901. And so, to me, it's not as simple as finding something to be true or untrue, because we're getting pretty out there with what the models actually are. There could never have been a primordial chaos, simply because scientists now know. Again, I'm not into the scientist knowing part, not into the 4 out of 5 doctors perspective. Let's get it demonstrable to the child. Let's not appeal to potentially false authority. The proton and neutron always and only coexist in their most exquisite interorderliness. So there could never have been a time when their integrity was not integrity. Now, I am not in this area, but my understanding was soon after the hypothesized Big Bang, there were a period of time where there weren't protons and neutrons formed because it was like too hot. And the gluons and the quark soup, I'm not in detail there, but the first 3 minutes, that kind of book. So either he doesn't know about that, or he doesn't think it happened that way, or he's suggesting that there's something about the relationship of protonness and neutronness that transcends the realization of even the physical energetic versions. I'm not sure. My question would be, physicists, synergetic colleagues, what is he saying here? 4. Universe is a scenario. Scenario universe is the finite but non-unitarily conceptual aggregate of only partially overlapping and communicated experiences of humanity. Universe is a momentarily glimpsed, special case, systemic episode takeout. When we start synergetically with wholes, we have to deal with a scenario within which we discover episodes like the frog the snake is swallowing. Universe is a scenario. So universe, being everything, has a certain setup. There's a certain board position and certain rules of the game. Scenario universe, the one we're in, is the finite but non-unitarily. So it's finite because there might be a lot of grains of sand, there might be a lot of hydrogens, but they're quantized, ergo discrete, ergo countably finite. But non-unitary. So it's not all happening at the same time. It's not simultaneous, but it's finite. But it's big. A lot of interacting pieces. Conceptual aggregate. So it's a conceptual aggregate because what we experience as being part of our experience, I guess, the nature of nature, experience of experience, is different things that are linked together in our concepts. So there might be an object on another part of the earth and then an object in my office, but they might be related through the topic, through an idea, through a conceptual piece. Or I might imagine a great circle that's going around the whole world or something like that, and that is a metaphysical thing that is not happening, whereas for things that are happening, they're discrete, they're not conceptual, and they are happening a certain place and time. Therefore, it's a conceptual aggregate of partially overlapping communicated experiences of humanity. So it's not like there's, again, could be wrong, could be right, that there's a shared human experience. And basically, humans are having partially overlapping experiences. 20 people are at a party, and person A and B are in their little experience, and these other people are over here with a slightly different experience. So they're all having the scenario party, but they're having different perspectives, different projections on the scenario of the party. The party, because that's a system. It's a system you can leave. Universe is a momentarily glimpsed, special case, systemic episode takeout. Now, I'm not sure what takeout means in this context, so that's one of my questions, but I know that angular takeout is something that comes into play when we're going to be talking about how many angles different types of shapes have. And this sentence seems to be getting at the idea that scenario universe is special case. It's actually realized through systems episodically. And so universe is like a snapshot. It's never going to return to it. And so therefore it's momentary. It's also always in the specifics, Blake's minute particulars. And it's always about systems and episodes of systems. Maybe they're getting takeout. I don't know. When we start synergetically with holism, We have to deal with the scenario within which we discover episodes like the frog the snake is swallowing. That about the animals may be an allusion to mythology, but also it could just refer to ecological observation of a snake eating a frog. Could be in a terrarium, could be out in nature. So the snake is swallowing a frog. And that's the specifics. But if you want to see the specifics and understand them in a way that's going to help you do something useful, harvest snake venom or do something ecologically, you have to understand the scenario, the food system, the scenario that is the niche. And so that is conceptual. The predator-prey dynamics or the population dynamics of the snakes and the frogs, those are actually conceptual metaphysical models within the observer's mind, not the frog's mind, not the snake's mind, not just floating out there in the magical ether, but in the local sense-making human's mind. There is a conceptual model integrating, for example, the human, the snake, the frog, and the niche. There's your tetrahedron. And I guess a question would just be, what are the implications of universe being non-unitary, and what is unitary? 5. Time is only now. Time and size are always special case, asymmetric episodes of now, whose systemic aberrations are referenced to the cosmic hierarchy of primitive and symmetrical geometries through which they pulsate actively and passively, but at which they never stop. The rest of scenario universe is shapeless, untuned in. See section 982.62 for cosmic hierarchy. Compare text at 133.103. Wow. So, many deep sections in Synergetics. Time is only now. It might be familiar to those who have thought about altered states of consciousness in other contexts, but it's the idea that time is an experience, and so the idea of time, past, present, future, is always in a moment. Lot like a William Blake poem, to hold heaven in the palm of your hand and eternity in a moment. That's not the exact quote, but Blake's an amazing poet and talks about these kinds of things. Time and size are always special case. So just like we were talking about the iron triangle, it's always a specific iron triangle. You can have the idea of iron triangles, but any specific iron triangle is actually going to be a special case in space and time. It's going to have size through time, and that size could change through time, like rust. Asymmetric episodes of now. So now is eternal, but it's always now. And there's this asymmetry with things that are almost like violating the perfectness of now with their existence. Systematic aberrations are referenced to the cosmic hierarchy. So, local systems that are aberrant are contained within a cosmic hierarchy. And what is that cosmic hierarchy of? Primitive and symmetrical geometries, through which they pulsate actively and passively, but at which they never stop. So, there's a cosmic hierarchy of what? Not of how much God likes it, not of shape, not of size, but a cosmic hierarchy of primitive and symmetrical geometries. So primitive and symmetrical geometries are seen as the unobservable case, whereas the systemic aberrations are the asymmetrical episodes. So we have a cosmic hierarchy of basically the good, the true, the symmetric, the beautiful, however you want to think about it, a cosmic hierarchy of these primitive and symmetrical geometries. And then that's being the reference point for these systemic aberrations, which are being pulsated through there, actively and passively, never stopping. So it's almost like the water of the ocean are these passive symmetrical, passive primitive symmetry geometries. And then a local aberration is like a little local chaos whirlpool, but it's not unstructured chaos. It's actually like a geometrical symmetry guided chaos, as the real turbulence actually might be. So this is why complexity science is so relevant, because it talks about these ideas like the geometry of space and time and about symmetry categories. So this is pretty interesting. It's basically just saying you got this perfect cosmic reference point hierarchy that's about the symmetrical and the beautiful and the primitive. And then local symmetry breaks or local changes in the geometry result in systemic aberrations, aka special case happenings, real things have to almost be an aberration from the true, true, and perfect, and beautiful, symmetric, all that, because that's how they exist and resist just being swept away in this pulsating ether. The rest of scenario universe is shapeless, untuned in. So that's like the seething, who knows, maybe 0 point energy, the energy of the vacuum. What is in the vacuum? Is it virtual particles? Is it something different? It's something that's shapeless and untuned in. Is it Maya? It's the primordial energy. But the energy isn't just like gasoline that's waiting to be lit, because synergetics isn't a combustion-based idea. Synergetics is a symmetry and a geometry-based idea. So it's like there's this 0 point energy that's ready to be harnessed with some sort of a fracture. But here we're going to be talking geometrically about how from primordial symmetrical geometries, asymmetrical event happenings can arise out of locally. And those are systems, but universe is the total thing. And then we'll just look at the figure. Figure 321.01, universe as a minimum of 2 pictures. Evolution as a transformation of non-simultaneous events. The behavior of universe can only be shown with a minimum of 2 pictures. How exciting and interesting. So here we see, of course, using some cultural knowledge about left to right and top to down, we see a chicken and an egg, paired, young chicken and an egg. We see a caterpillar and a butterfly. We see a tree in the winter and a tree in perhaps the spring with more leaves. A melting ice cube and a melted ice cube. So think of a dotted line down the middle. And it's sort of like questions that we've heard before. What came first, the chicken or the egg? Well, another way to ask it would be, what came first, the caterpillar or the butterfly? Another way to ask that would be, what came first, the tree in the winter or the tree in the summer? Another way to ask that would be, what came first, the water that's in the rain cloud or the water in the ocean? When they're all part of these cycles. And so anything that returns to the same point has to be oscillatory. And so it doesn't make sense to talk about an oscillatory system, which part happened first. So we're stepping outside of the chicken and the egg paradigm because we're saying unity to be chickenness, butterflyness, which is about the species, not just the one with the wings. Butterflyness, the unity that butterflyness is at minimum 2. You need at least 2 states to oscillate back and forth between to ever return to any state. So that's pattern integrity. That's dynamical integrity. Now, you could have 5 instars of larva, and then the pupa, and then the young adult, and yes, you can have more than 2. You can have unity of many more than 2. Organs, cells, nestmates in the ant colony. But unity is a minimum of 2. If you just say, yeah, water is what's in my cup, you haven't actually scoped out what water is. Now, if you had water and your sink, that's already conveying more. If you have water and the water system, we're already starting to see this holism being baked in, because everything is going to be related to other topics, itself in the past and in the future, teleos and all the efficient cause, all of the Tinbergen's 4 whys, Aristotle's whys. And we'll think about these systems, which are subsystems of universe, as always requiring multiple perspectives, different perspectives from humans, but also different views. So development. It's relational, it's development thinking, it's complexity thinking. So really a beautiful figure. And that concludes the first pass on universe. The last part we'll talk about today is what is system, and that is going to be slide 230, section 230, dare I say, and that is number 400. Section, all right. Here we are. 400, system, 400.011. A system is the first subdivision of universe. It divides all the universe into 6 parts. First, all the universal events occurring geometrically outside the system. Second, all the universal events occurring geometrically inside the system. Third, the universal events occurring non-simultaneously remotely and unrelated prior to system events. Fourth, the universe events occurring non-simultaneously, remotely, and unrelatedly subsequent to the system events. Fifth, all the geometrically arrayed sets of events constituting the system itself. And sixth, all the universe events occurring synchronously and or coincidentally to and with the systematic set of events uniquely considered. So, awesome and very cool stuff from Bucky. We're going to define system in the sense of systems thinking. So, complexity theory, complexity science, systems innovation. Colleagues, this is our calling to understand synergetics and put systems theory within a broader informational, geometric, thermo-cybernetic framework. We're going to find out that system is at minimum tetrahedra. It has to have at least the space enclosing nature. It has to be the minimum space enclosing thing. Because remember, Bucky in the classroom. If it's not space enclosing, it doesn't exist. Now, what's the minimal space enclosing thing? Well, that's just 4 points, the tetrahedra. The minimal space encloser isn't the cube. Because the cube, you got 4 points on the bottom, 4 points on the top, you need 8 points. So you could have 2 tetrahedra for that many points. So instead of having the cube with the 1 by 1 by 1 equals 1 as the unit of volume, we're going to go minimal system is tetrahedra with 4 points. And there's 6 things that system is going to give us, minimal system being tetrahedra. And let's go through these 6 parts and maybe even link them to active inference, to the free energy principle, the research of Carl Friston, because I think that is something that we'll bring into the picture soon. So first, what happens when you define system? So when you define that tetrahedra, physically or nationally or conceptually, what is it that's happening? First, you're separating out all of the universal events occurring geometrically outside of the system. Those are external states. Second, all of the universal events occurring geometrically inside the system. Those are internal states. Third, all the universal events occurring non-simultaneously, remotely, and unrelatedly prior to the system events. So those are parts of the external states that don't matter. They're the elements in the Markov blanket that are 0. They're the conditional independencies. These are the parts that don't matter about the outside world. Fourth, the universe events occurring non-simultaneously, remotely, and unrelatedly subsequent to the system events. So that's like the other side is actually on the ingress, you have which nodes of the universe don't have a causal influence, the parent nodes of the Markov blanket. Which nodes don't influence the system of interest. So those are the zeros in the adjacency matrix for causal influence. Now we're looking at the zeros in the adjacency matrix for the action of the system. So these are parts of the system that are going to be after and unrelated to the system events. So we have pretty interesting stuff. Fifth, all the geometrically arrayed sets of events constituting the system itself. So those are the hidden causes within the system, the architecture of inference. And sixth, all the universe events occurring synchronously and or coincidentally to and with the systematic set of events being uniquely considered, sense and action, the Markov blanket. So quite amazing and beautiful. And it really moves us towards the direction of wanting to take these developing formal models for active inference and add them to the developing formal models for synergetics. What would Bucky do? Number 2, a system is the first subdivision of universe into a conceivable entity, separating all that is non-simultaneously and geometrically outside of the system, ergo irrelevant, from all that is non-simultaneously and geometrically inside and irrelevant to the system. It is the remainder of universe that is conceptually constitutes the system's set of conceptually tunable and geometrical interrelatability of events. Again, it's just the framework that I'm familiar with, so I put it into complexity science and active inference, but I would love to hear other perspectives on what these portions mean or what other things arise for other people. So a system is the first subdivision of universe into a conceivable entity. So this reminds me of Friston's particular physics, or basically a theory of everything with cheeky British quotation marks. Because if you're going to be having something that's conceivable, able to be conceived of, able to be a concept, It must have delimitation. And that implies separating out everything that is non-simultaneously and geometrically outside the system, ergo irrelevant, from all that is non-simultaneously and geometrically inside and irrelevant to the system. So in other words, I have the person in front of me, and there's things that are geometrically inside of them that might be irrelevant for the medical condition that we're discussing. Now, it doesn't mean that they're everywhere or many or little. It could exist. There's things that are within the country that, with respect to the variables that you're caring about, those are conditional independencies. So there's irrelevancies or conditional independencies within the geometry of the system. And then also there's dependencies that are distant in space and time. So there might be things that happened in a different place, in a far off land, a long, long time ago, that impinge on a person and their body, for example. So when we're thinking about system, which is conceptual because it's a conceptual entity, we don't just want the outline of the system. We don't just want to wrap it and measure how big it is. We want to conceptually understand system. Now, Tensegrity architecture is a special case where the idea is the sculpture. So there's actually an isomorphism. Tensegrity sculptures are like the bridge between Tensegrity and Synergetics. But when we're talking about pure thought systems, then it's not a one-to-one. So we have to think about the things that matter outside of the system and the things that are conditionally independent inside of the system. It is the remainder of universe that conceptually constitutes the system set of conceptually tunable and geometrically interrelatable set of events. So, two sides of the same coin. Saying that we're going to discover the zeros in the adjacency matrix is like saying we're going to discover the non-zeros. Because if you discover the non-zeros, the other ones are zeros. And if you discover the zeros, the other ones are non-zeros. And so what Bucky is saying is that start with system. And then what system should we start with to drill down? You got to start with the biggest system, which is universe. So it's so big, it's not a system. Everything is a subsystem within universe. And so there's this design idea of starting with universe and then discarding irrelevancies. So instead of starting with the little and then building up, trying to generalize, build, you don't know if you got a poison pill early. So Bucky's saying start with universe and then discard irrelevancies no matter where they are in space or time. And you're going to be left with the tunable geometric thought relationships about how events are related. So this is so critical and so interesting. 3. Conceptual tuning means occurring within the optical rainbow range of human sensing within the electromagnetic spectrum, and wherein the geometrical relationships are imaginatively conceivable by humans independently of size and identified systematically by their agreement with the angular configurations and topological characteristics of polyhedra or polyhedral complexes. So, conceptual tuning means occurring within the optical rainbow range. So, pretty interesting. Conceptual tuning, so we can tune the concepts within a certain range. So, there's ranges, a guitar string. There's a range you can tune each string within, but there's ranges that you can't hear. It can be so tight or so loose you can't hear it, and it could also be so tight or so loose it's broken. So, a system can break. We shouldn't take synergetics to be a naive theory that things don't break. Things locally can break. When they aren't breaking, and they're in the tuning or the resilience regime, which is where most systems that exist are at, that means they're occurring within a band that can be thought of as like this Goldilocks rainbow. So the rainbow, as we perceive it with colors, with color vision, is from around 400 to 700 nanometers of being the wavelength of light. And so it's such an infinitesimal fraction of the spectrum. So you got, from light moving on down, 5G, 4G, Wi-Fi, all the stuff going out down to radar and other very, very long wavelengths. So this isn't a conversation about electromagnetics or health or about what is different or similar about those different wavelengths. It's just to say that the conceptual tuning is happening in a tiny band of that space. So that's like saying all the colors in the world for drawing, for art, for making beauty, all the colors in the world are like a little slice of the pie on a very large continuum. And so even though it feels like there's so many degrees of freedom with the rainbow, that is actually just the degrees of freedom of our experience. And so if we had a bigger range of wavelengths we could operate on, it would feel as rich and as diverse as the rainbow, or as we want it to be, because the rainbow is like the range where our ideas can be, we can see gradations within the rainbow. Outside of the rainbow, you can't see gradations. So if somebody tells me two words in another language I don't know, and they say, well, this word is different than that word, it's like, it's not in my rainbow. So I can't, it's outside of my wavelength. The guitar string is not tuned. A lot of metaphors, but it's like saying it's outside of the conceptual tunable band, the zone of control from a cybernetics perspective. And that's, of course, happening within the electromagnetic spectrum, wherein the geometrical relationships are imaginatively conceivable by humans independently of size and are identifiable systemically by their agreement with the angular configurations and topological characteristics of polyhedra or polyhedra complexes. Okay, so we've gotten at this idea that metaphysics means the generalization, and that means non-physical, and that means that it's independent of size. Because the special case is not a generalization, and it is dependent on size, and it is physical. So it's just simple. Physical things are special case, metaphysical things are generalizations. Now, these generalizations are identifiable using a system, turns out Synergetics is that system, by their agreement with the angular configurations and topological characteristics, which are the non-geometry. Got angle, topology, connectedness and angle, and then geometry, shape, we're leaving that to the side. It's the characteristics that generate these geometrical polyhedra or polyhedra complexes. And just the first line here, all systems are polyhedra. So here, systems are defined by their insideness and outsideness, and therefore they need to be a polyhedra. And you can't have a polyhedra that's flat. Remember, on the plane, shapes on a plane, they're not real. They don't enclose space. That's fake. Paper has dimension, height, length, and width. So the only thing real is space filling. And we're going to have space filling down all the way down. And systems are taking up space. The special case system, the hula hoop on the table takes up space. The sugar cube takes up space. And the idea doesn't take up space. It's metaphysical. It's a generalization. And synergetics is the geometry of thinking. Well, what an interesting first discussion in synergetics. I think that's where I will land the plane for today. But I hope that it was accessible, pragmatic, and interesting. Maybe I'll choose different adjectives or the same ones each time I do one of these. I don't really have a plan for what to cover from a topical or just content status. So if people are like curious, they want to participate, if they want to recommend somebody to come on, or we could structure an interview, I'd be happy to host a presentation by somebody. Also, we can always just go back to the text and try to understand it and try to build on it. But I'd say the more, the merrier. So if you're one of the few who are listening right now, consider yourself invited to participate. Please just contact me whenever you are listening, and let's do an interview, or let's do a Q&A, or let's just try to hear more perspectives, include more people, have a more accessible and rigorous synergetics, a real participatory field. And there's so many reasons why that's important now. So it's been an honor and a pleasure, and Bucky be praised. So thanks everyone for listening, watching, live, replay. It was fun. So I hope to see you in a future Synergetic live stream. But till then, peace.